pound mixture at $4.99 per pound.
Okay. All right. So that's a lot. Okay. So we have some hints. Read the problem carefully. I think we just did that. Lay out the quantities in a table. Oh, got a table here for you. Sometimes when working with percent concentrations, it's better to show the quantities with different containers and label them. So we're going to do some drawing. Okay, Lux, put your book away. Don't want you to miss anything important here. I know you're probably at a really good part. I'm sorry. Okay, so imagine, if you will, that the grocery store has like two giant containers. One is walnuts, one is raisins. I don't know who wants to mix that, but they do. Okay, sounds gross. They have to figure out what is the ratio, like how many walnuts do they need and how many raisins, so that when they put it together, it's going to cost $4.99, right? So right away, you should be thinking to yourself, what am I going to need more of, raisins or walnuts? Why raisins? Because it costs less. So you're going to have more of whatever costs less because they want the mixture to cost less, right? So you have to think in your mind, all right, my answer should have less walnuts. Help yourself out. Figure that out ahead of time so you can kind of check your common sense here. Okay, so I'm going to try to mix these up. How many total pounds do I have?
100.
100. So when you find your answer, should it be greater than 100 when you add them? No. All right. Whew. Everybody.
It's just going to be $500. Oh, Mackenzie.
Well, no, it'd be if you wanted to buy some, it would be $4.99 a pound of whatever you bought. Like, so you get up there and you get a scoop, right? Imagine they like mix it up and you get a scoop and you, like, it's kind of like going to the candy store where like you mix the candies and they figure out, right?
Oh, and then I always make some.
Sure.
But I don't. I know.
I know you don't. No.
I of course not.
Okay. So here's what we're going to do. I set this up for you guys. We're going to let the amount of walnuts equal X. Okay? So walnuts, amount in pounds, we don't know. That's going to be X. We don't know. Okay? So if the total pounds that I want is 100, then raisins is going to be 100 minus however many pounds of walnuts I have. Right? And the mixture is going to be 100 pounds. How much does it cost per pound of walnuts? $7.99. How much does it cost per pound for raisins? $3.99, right? So far not so bad. We're just taking it and we're organizing it. What do they want the final product to cost per pound? $4.99. Everybody's with me so far, right? We're all on the bus together? Nobody's left behind at the stop? Okay. Total cost for the walnuts is going to be $7.99 times X. Right? However many pounds times $7.99.
Wouldn't that just be $7.99?
It would be, but it'll make sense when I show you why I put it like that. For raisins, it's a little different. It's $3.99 times the quantity, 100 minus X. $3.99 times this will be the total cost of the raisins. So I'm just basically multiplying across. And then our total cost of our mixture, we want that to be $4.99 times 100. Everybody's with me? Kind of.
Yeah.
Okay. I'll take kind of. So now we're going to write an equation, the walnuts plus the raisins to equal the mixture. So luckily, we have that information here. This plus this will equal that. Whatever. We don't know what X is. We don't know yet. So that's why we have all that variable in here. So I've got $7.99 X plus $3.99 times 100 minus x. And it's going to equal, once I figure out what that combination is to be perfect, it's going to equal $4.99 times 100. And this is a minus here, in case you can't see that. Okay, so now we're just going to solve this like a normal equation. First thing I'm going to do is I'm going to distribute this. So I'm going to get 799x plus 399 minus 399x equals 499. Everybody with me? Okay. So I have some like terms here. 799x minus 399x is 4x. Subtract the 399 from both sides. I get x equals 25. What does that mean? 25 what? Hayden? Of?
Mixture.
What does x equal? Look back at your table. What does x equal? Walnuts. Okay, so I have 25 pounds of walnuts. Which means, how many pounds of raisins do I need?
75.
Whew, that's a lot of raisins. And that's my answer. How did I get the 75? Yeah, I knew I needed 100 total pounds. So 25 plus what? Or 100 minus 25. There you go. Not so bad, right? Woo. I don't think I would want to buy that mix. What? You like raisins? Okay. Well, then you could just buy, yeah, you wouldn't even need to buy that mix because it's cheaper just to buy raisins. Okay, take a second to read this question about the different types of teas. I actually did research on this. Tea is expensive, FYI. Okay, really quick. Which amount of tea am I going to have more of? Why hibiscus? Okay. Is our final total closer to 12 or closer to 40?
12.
It is closer to 12. So even though, yes, it's cheaper, that's not always the reason, right? Because if we wanted to make a 16-pound can that will cost $30, then what would I have more of? Jasmine, because it's closer to 40 than it is to 12, right? So the one you're going to have more of is closer to the price you're trying to get to. Okay. All right, so it says let X equal the amount of hibiscus. Cool. Easy peasy. How many total pounds do I want? 16. So jasmine tea is going to be 16 minus that X, because once we figure that out, we'll subtract it, just like we did with the walnuts. And the mixture is 16. Cost per pound of the hibiscus, $12. Jasmine is 40, and we want our mixture to be 25. And then our total, when we multiply across, is 12 times X. 40 times 16 minus X. And 25 times 16. Okay, we have everything we need for our equation in this column here. Hibiscus plus jasmine equals mixture. So I've got 12x plus 40 times 16 minus x equals 25 times 16. Here we can draw a fun arrow. Okay, you're on your own. Go ahead. Use your calculator. Solve the equation. You're going to get x, and then figure out how much jasmine there is because it's 16 minus that x. I'm going to freeze my screen. We will compare our answers. It's not going to be a perfect number for this. You're going to have to round to the nearest tenth.
I do this wrong for like 3 years. It's terrible.
Oh, yeah.
What did I do wrong?
Oh, I got 38, not 20.
That's how many pounds
I didn't know.
So we need 8 6. Yeah, figure out 48. And
How'd we do? Are we mixture problem experts? I mean, there's definitely a system, right? Like, you're just learning a procedure in order to find this.
Does it get harder now?
Yes,
What the heck?
it does. I'm not gonna lie to you. I'll never mislead you. But yes, it does get more difficult. Okay. Example 3. We'll see how much of this we can get done before you guys take off today. Woo, chemistry. Who likes chemistry? Mixing potions, yeah? Elephant paste, is that what they call it? Where they mix stuff and elephant toothpaste, yeah? Okay. We have 25% concentrated acid solution and a 75% concentrated acid solution. How many liters of each solution does the chemist need to make 500 liters of a 55% concentrated acid solution? Whew. So we have a weak solution, I mean it's still pretty, and then a super strong one. We want one kind of in the middle. So is it going to be more of this solution or more of this solution? More of the 75% or more of the 25%?
More than the other one.
The other one?
Yeah. I was pointing.
You were pointing. So you're going to need more of this because 55 is closer to 75. So that we have that in our mind, right? So we're going to draw a picture, guys. We're going to pretend like we have some solutions. So we have a 25% plus a 75%, and we want that to equal 55% concentrated solution. So this first column is pretty basic. We're just going to rewrite these numbers as decimals. 0.25, 0.75, 0.55. And then we're going to make the 25% solution our x. Guys, I literally make this decision based on what's given to me first. If you wanted to make the other one x, then you would just rearrange it on the table. So there's no wrong one to choose for your x value. You just need to stick to it and then choose your other things around that. So if 25% is x, then the 75% is going to be 500 minus x, because remember they want 500 liters. So this is very similar to what we were just doing with the walnuts and raisins and teas. It's just people get a little nervous when they start to see percentages of things. So this is going to be 0.25 times x, 0.75 times 500 minus x, and 0.55 times 500. And we'll stop right there. I know some of you are getting antsy. You want to pack up your things. We'll finish this tomorrow. There is no homework.